is set up a Desmos page again. This Desmos has the standard cosine function, but I've set up a slider for C and D, so hopefully you can see that where you're sitting. And that's what our standard cosine function looks like. And I might just change the settings again so it has a step of pi, and I'll just leave it at that. And I've set the slide up to show you what C and D does. Do you remember what C and D does for the standard function? What does C do?
Translate.
Go. Up. C is the horizontal. D is on the outside. So anything on the outside of the function represents vertically, and anything on the inside is a horizontal movement. So C just moves the function horizontally if I change my C value. D moves the function vertically. And that's essentially all you need. Okay, and the C is not as obvious, but the D is hopefully reasonably obvious. When you just actually sit back and think about it, if I've got a function y equals sine of x and I add 2 to that, it's going to take every point that was here and move it up 2 spots. That's what the add 2 to it does. So the D is just moving up and down based on whatever D is. The C is less obvious than the D, of course, so don't worry too much about that, as long as you memorise and you know those two factors. And we've got this epsilon here as well, so I use A, B, C and D because we use that as standard notation for all functions. The textbooks uses N and epsilon, which is exciting. So there we go. So the effects of C are that C is a horizontal translation. And so that's what you need to remember. Which of the 6 things, there were 6 things, peak, trough, midline, amplitude, phase shift and period, which one of those things do you think C represents?
Phase shift.
Oh, I've got 2 answers, period, phase shift. Hands up for period. Hands up for phase shift. More votes for phase shift, and you're right, it is the phase shift. Good. So the phase shift is how far it's shifted away from the y-axis from where it originally started. But I'll show you that now, what I mean. So here's a couple of examples. First one just has a C value. Sketch the graph of y equals cos x minus pi on 3. So to do this, the first thing I'm going to note on this graph is that A equals 1, B equals 1, and C is equal to pi on 3. Remember, we write our standard form as x minus C, so in this case C takes that positive value. C is equal to pi on 3. The amplitude is 1, which means it goes up to a 1 maximum and down to -1. So I've already got that information. There's no change in midline because, and some of you will have guessed why that is, but we'll get to that a little bit later this lesson. The amplitude is 1, B is 1, and B being 1 gives us this relationship we learnt last lesson. The period, T, is equal to 2 pi over B, which in this case is 2 pi over 1, which is just 2 pi. So what that means, in terms of B, if I do this stuff in purple, is that if we start the function here, then up to 2 pi is where we have a full cycle of the function. So in this case, it's a cosine function. If it starts here, it goes down, up, and then back to the top in that one full cycle. That's what the period represents. But we do have a phase shift, so you have to be careful here. This is our phase shift. It's a horizontal translation, so the whole graph has moved pi on 3 this way. So instead of starting at 0, our cosine function will actually start at pi on 3. There. And I'm going to draw a little green dotted line down here. That's where our cosine function is going to start, or one cycle of the cosine function. And cosine starts at a peak, so it's going to start there. It's going to finish 2 pi on, because 2 pi is our period. So that's about here. Can anybody tell me where it's going to finish? What is that value on the x-axis there? 2 pi on pi on 3. 7 pi on 3 is exactly right. Perfect. It's a skill to have. You've got your calculator, obviously, but there is a tech-free exam. And we might ask you to do some fractions in a tech-free exam. This is the fractions question. Pi on 3 plus 2 pi. 2 pi can be written as 6 pi on 3. Pi on 3 plus 6 pi on 3 is 7 pi on 3. That's just a skill you need to practice. So as you're doing the questions in a textbook, try not to use your calculator. Try and practice that skill and get those fractions sorted. So we know it starts at a peak because it's a cosine function. It finishes at a peak in the middle, which I'll just do a little dotted line down here. Between pi on 3 and 7 pi on 3 is 4 pi on 3, because between 1 and 7 is 4. That's the midpoint. It has a trough, and the function goes like that. And of course, remember we talked about the fact that we should continue our function on to show a bit more of it in both directions. That's our function. This is a cosine function that has been horizontally translated pi on 3 that way. Nothing else has actually changed. The amplitude's still 1, the midline stayed the same, the period is still 2 pi, so nothing else has changed from a standard cosine function. Are there any questions on that one? The next example gives me a chance to gear us a little bit more towards the ultimate goal, which is if you have an A, B, C and D that have all changed from the standard, you sketch it. And I'm going to show you in this question, and I'll continue to show you from now on, the way that I would sketch it, which involves doing kind of what I did above, but basically you create a box and you build your function inside that box, and then you can continue that function on. I think it's the easiest way. The textbook does it slightly different, so I urge you to compare. Read the example in the book and compare. So for this one, the first thing I'll do in any question like this is I'll identify the key values, and then I'm going to start to identify what they mean in terms of A, B, C and D, in terms of peak, trough and all that kind of stuff. So my A is equal to 2, my B is equal to 1/2, my C is equal to pi, and in this case my D is equal to 0. We're still not talking about D too much yet, okay? So my D is equal to 0. And what it means for me, it means that B is equal to 1/2, means that my period is equal to 2 pi over 1/2, which is 4 pi. So that's my period. A is equal to 2, means that my amplitude equals 2. So A was directly related to the amplitude from last lesson. C is equal to pi. That means that my phase shift equals pi. So I've got a shift of pi so it's x minus pi, so pi in a positive direction. So if I draw this onto a set of axes, I've got my amplitude, which I'll do in green. Upper bound as it goes up to 2, lower bound as it goes down to -2. So my peak and trough are the amplitude above the centre and the amplitude below the centre. So it goes up to 2, down to -2. My C value, my phase shift is pi, so I'm going to do that one, let's say in purple. And I draw a little dotted line down here, and that means I'm starting at pi. My period is 4 pi, so I've not really done a good scale here. In fact, I'm going to just take that back and change my scale a little bit. I'm not ever going to get to 4 pi on that scale without it being unreasonable. So let me just try that again. I'll put pi here. That's probably a bit better. So there's pi. My period is 4 pi, so I'm going to move on 4 pi from my original phase shift, and hopefully you can work that out. That takes me up to here, which is 5 pi. And can you see how I've created a box? I have one full cycle occurring inside that box I've created. If I can work out my line that represents the peak, my line that represents the trough, my line that represents where the function starts, and then a period on from that, which is where the function ends, I'll create a box. And in that box, I can draw a function. This is a sine function. A sine function starts at the midline, heading up. So it goes midline, and then at the middle of the box, it's midline again. At the end, it finishes at the midline. At the 1/4 mark, it reaches a peak. At the 3/4 mark, it reaches a trough. And my function looks like this. And then just to carry that on a bit, goes like that, goes like that. So, and it's that easy. If you understand how to translate A, B, C, D to peak, trough, amplitude, midline, etc., you can create this box and create the function really easy. Then you've got a calculator, bam, 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 and you've verified that it works. Okay? That's example 5, and that now gives you an idea, not necessarily a full set of skills, on how to use A, B, C, and D. A, B, and C. We haven't talked about D yet, and I'm trying to break it up into chunks, so I'm going to leave D to maybe do later this lesson, hopefully do later this lesson, but I want to give you a reasonable amount of time to practice this C skill. So I'm going to leave it there for now.